Hello everyone, I am Asif Ali and you are watching CGHOW video, and in this tutorial we will cover some of modules in Niagara particle system. So as you know, I am working on this intro to Niagara series of basic Niagara tutorial, and in this we will just cover some more modules in this series. So let's get started this tutorial. First of all, subscribe my YouTube channel and also click on bell icon so you will receive all new video notification. So I have this empty scene and this empty folder. So I will create a emitter here, and I will take I will take a fountain or burst. Let's take a burst and burst. And I have these particles that are bursting and just falling on the ground. And if you want these particles to be twinkle, I mean to scale up and down frequently, so what will you do in Cascade? In Cascade, I'll open a Cascade and I'll just use a radial ramp, and I have these radial particles here now. And if you want to, I'll just take a sphere so they will look separate. If I want to twinkle them, what I will do, I will go to size over life and I will just log these, and this is the size curve here, and I'll just key for twinkling them, so I can just make them up and down. Okay, and still the key is very taking too much time, so it's not very fast. So if I make the life shorter, like 2, now you can see these are twinkling because in this lifetime they are scaling up and down. So you have to maintain this curve. But in Niagara, if I open this, I have this, I will just increase the color so it will look red. Okay, so I want twinkling them. So first what I'll do, just make them unaligned, so these are just point, they are not stretching, and I will just turn off something and initial size is 1010, turn off the mask. So I have this and I have this cone. I'll just decrease my gravity so you can see them properly. Still they are not point, so turn it off. Now these are points and I want to scale them, so I can take a Sprite size scale, and this is the size, so I can just make them float, and now I can use curve similarly like I used in Cascade. Now I can animate this curve, but the shortcut way of this is to use a sine wave. You know how sine wave looks. In my Cascade I made this curve, so sine wave works like this, but you can control that very quickly. So like I don't use this curve, I have this float, and I will take sine, and now you can see these are all scaling up and down. If I decrease the period, they are scaling up and down very fast, but they are all scaling together, they are not scaling randomly. So for that, first check the life. This is random, but still they are not random because these are linked with normalized angle emitter edge, so you have to link it with normalized edge. Now you can see these are randomly. So if I make it 0.5, you can see this is twinkling. Here you can increase the size, and you can see how quickly you can maintain this, and you have the twinkling effect. You can use a star shape for this. So if I use a flash here, if I have a flash texture, not this one, let me just check textures. So like this one is using in this material, so I will just browse this and just use this here, and now I will just increase. Now you can see, and these are not random rotation, they are, so I will just use random rotation here. I will make it uniform, and 1 and -1, and I want random rotation over live, so Sprite rotation rate and make it uniform. So this is not visible, like this is randomly rotated. So I'll just check. I'll just turn off my Sprite scale sine wave. I'll just increase my size, and now I will just increase the power. So it's not rotating. So what I'll do here, I'll just delete this, and I'll take it again. So now they are rotating because they were not rotating on delta. And that is where they are supposed to be rotated, but they are now rotating on one angle, one side. So I will make it random. So now they are, but you can see because I use random values, some are not rotating because it's taking the middle value. So what you can do for this, just make it this float, single float, and in spawn, particle spawn, just take a float. You can take it from here also and name it random rotation, whatever you want. Spelling is mistake, but it's okay. And here you can just connect this with your random, what was the name, random rotation. So just connect this random rotation, and now this parameter is connected with this parameter that is on spawn, and now you can make it random uniform range, and now you can see these are all rotating randomly. So this is how you use these parameters, and I think sine wave is clear, but I will show you one more example for the sine. So you have, oops, I just close my folder. So this is my folder. You have a system here, empty one, and I have this default emitter which has nothing, and so I'll just take a mesh renderer. I'll take a cube, 1 meter cube, default material whatever it has. Then I'll take a spawn rate. I will take spawn rate, make it like 20. So I have this cube, and I will take a velocity here. um, add velocity, not random, 50, 200. So it's animating it, it's moving it upward. So what can I do here? I want to scale them like so it will look like sine wave. So I'll use 500. So here I will use mass size scale, and I have this 3 vector, so I want to break it. So now I can use sine, so make it 1 1 all, and on which axis I want on x axis. So on x axis I will take a sine, and now you can see, and I will also connect it with normalized edge and scale to 5. Now you can see, and I can use this bias. So let's make it 0. So now you can see this sine wave properly. This is how it works, and the mass is here because of this random light. I will make it 2 and 2. Now you can see it properly. So if I make it 5, this is making a big curve, but I can just make it shorter here. So this is fine. You can easily. Now I think sine is clear to you and how to use it. So you can use it anywhere, not for a scale. You can use it anywhere in this particle system. So I think sine wave is clear. Now I will take one more system, and in this we will cover curl noise. So I will name it curl noise. Spelling mistake again, so it's okay. So I'll take a default emitter that I use in all my tutorials, and I will take a sprite renderer, and I will take radial, and I will spawn rate maybe 200 spawning, and I have no velocity. I can add velocity here. Add velocity, so they has velocity now. I don't want velocity, I want random movement of particles. So in Cascade you have orbit for random movement, and if orbit is not properly working, whatever you want, so you can use in GPU, you can use vector, local vector field. So in Niagara you have curl noise, although you can use vector field to fix it. So first you have to just increase the value, and I'll just use this pan noise, so it will be randomly animating. So now you can see if I increase too much, and this is the frequency, so let's make it 0.01. Now you can see how it's working, and I will go to my particles and make it like 2 and 2. It's not working because of calculate size by mass, so I will just turn it off. Now make it 5 5, and I will make it GPU because I want lots of particle, and I will increase this to 2000. Let's have some colors. So like I will take oranges. Here I will take some purplish, and these particles are just spreading here, so you can use drag, fix this, and like 3, and just compile the full build. So now you can see this is stopping them, and this is my curl noise. So this is how it works. and you can see. So you can just duplicate your emitter again, and you can just change the curl noise pattern. So now you have two. You can again paste. You have three emitters. Now you can change this two. So you have three, and it looks nice. So this is how you can use curl noise. So basically this is intensity, this is frequency, and this is the animation of curl noise. Like in Cascade, when you use vector field, you have vector field rotation rate, so that rotates the box of vector field. So this is how frequencies animate. So this is the curl noise. This is easy and this is very obvious. So now the third, we will use Point Attractor. So for that I will take again a system, empty one, Point Attractor. I will take again default emitter very quickly, and I'm doing it from scratch again, so you can just understand what I am doing. Although I can use my previous emitter, that curl noise, but I'm just doing it again so you can see what I'm doing. So I will take this pawn, make some particles. So you have these particles, and like you have velocity or curl noise, anything means your particles are moving, and you want them to attract on some point all the particles. So what you will use here in particle update, I will take a point attractor, and you can't see this physically here because in Niagara we don't have visible or spheres like in Cascade. In Cascade, if you are taking sphere location, you can just turn it on 3D draw, so you can see this sphere, and now it's easy to visualize how scaling is. But in Niagara it's not there for now. So you have this attractor point, and I'll just turn off fall off, and you have two options here, strength and radius. So the radius you can't see, but you can visualize. If 100 is here, you can increase. And third is position, on which point the attractor will attract the particles. So like if I just increase the radius, so it will cover whole thing, and now I'll increase the strength. You can see this is attracting, but this is attracting on the same point from the particles are emitting. So I'll just change the point. So for this I will make this local, so you have this value is still 0, so it's still the same point. I will move it on x-axis like 20, 50. So now you can see 50 is somewhere here, and these particles were going upward, then they are attracting to this point, and because the intensity of attraction is high, it's just passing through and going again here. So if I decrease the value like 5, you can see these are attracting, but not much. See, on one value these are attracting not much, and you can just move this side or anywhere there you want, and you can increase. So I have also one tutorial for this, that is you can watch, and the tutorial is, let me check, this user attractor for. So I am using attractor position in Blueprint, so I can just animate, and this is the one method to use point attractor and update. So it will continuously updating, and particle update and particle spawn, you have difference in this. So like if you work in Blueprint, you have two nodes, event on play and event tick. So event tick works on per frame, so like particle update, and event on begin play is like spawning. So it just whatever happens when particle spawning, and it's whatever happening over life of particles. So now point attractor is happening over life of particles, and if I put it here, it will just work on the spawning time. Like I'll just turn it off, and I'll just turn it off my velocity. So I don't have any velocity. I'll just take a sphere location and I'll just make it maybe 10. So I have no velocity. So in spawn rate, I spawn particle spawn. I'll take point attractor and I'll just increase this. And if I increase this, it will attract obviously. If I make it negative, it will just spread. So I will make it negative. So you can see spreading. It looks like it's spreading continuously because spawn rate is continuously spawning the particles. So if you have a burst here, it will work like this. So it will just spread them, and that's it. So this is the difference to use it here or here. And if you want to use this parameter in manually, like if you have this spawn, and you can just have two spawn and you can just turn it off one, or you can just turn it on all together. So I'll just use this. I'll turn it off this from here and turn it off here. So point attractor is, and I'll use velocity. So I want to animate this value. So what I will do, I will make it user parameter. So it's connected to the user parameter that will reflect here. I can change value from here, and if I drag it here, I can change the values from here also. So it's attracting on 0. I can just move it up. Okay, so it's just moving up. So now what I can do, I can connect it with anything. So like you have this sphere, I will make it just movable. Go to blueprint. I have lots of blueprints, so I'll just use my tick here and select this particle system. Take a reference of this. Get Niagara variable. Take vector 3 because in here you have 3 xyz, so it's vector, not float. And just copy the name from here, copy, paste, and I want this value to connect with this sphere. So just select the sphere, take a reference, get location, get actor, location, connect it here, and just connect this here. I think I took wrong variable, so I'll just take vector, yes, paste the name here and just connect the location here. So my attractor position is connected with sphere, so I'll just play. This is not attracting anything now. So in your particle system, oops, I just forget to. So play. Now you can see this is attracting to sphere, and now you can see I'm moving this and it's just updating the attractor location. So it's fun. You can just use any parameter and just connect it with anything. So you can just connect it with character, so the particles will follow the character. Okay, so I hope this is clear, and in this tutorial we have learned curve, noise, sine wave and point attractor. So if you have any queries, comment below the video, and don't forget to subscribe my YouTube channel CGHOW. Thank you for watching, keep learning, and I hope that you have an amazing day.